Okay, we are going to begin with this problem. It says a solid lies between the planes perpendicular to the x-axis at x equals 0 and x equals 19. The cross sections perpendicular to the x-axis on the interval from 0 to 19 are squares with diagonals that run from the parabola y equals negative 2 squared roots x to y equals positive square roots 2 squared roots x. So, and you want to find the volume of the solid. So I just wanted to take a minute to remind you of a website called Desmos. I'm on my iPad here, but you can just type in www.desmos.com and it will do graphs for you. So you can go ahead and see that y equals 2 square roots of x is that sort of upward square root, and then negative 2 square roots of x looks like that. And if we want to look at it from 0 to 19, we would just, it's going to have that shape along the x-axis. So just kind of continuing that way. So we have the idea of it's kind of like a parabola that runs along the x-axis. So here's our 2 square roots of x, and then here is our negative 2 square roots of x. We want to look at that from x equals 0 to x equals 19. And we're going to consider this shape that would be formed if we have squares whose diagonals run perpendicular to that. So they run along this. So you can imagine the squares kind of come out. So it kind of almost looks like it's hard to show this in 3 dimensions, but you want to think of almost like a football that's kind of real pointy, So these points come out and they would have varying heights, but that's what it looks like. And so we learned in this section that to get the volume of this shape, so here they would be smaller, but they would come out like that and go down like that. To get the volume of this shape, we would want to just integrate the area of one of those squares along the x-axis from 0 to 19. So the squares are going to increase in size, and so we want to add up their areas from 0 to 19, the area of the square, dx. Okay, so let's consider one of those squares, one of those arbitrary squares. What do we know about it? Well, it has a diagonal that runs from negative 2 square roots of x to positive 2 square roots of x. So the length of the diagonal is going to be you would find that distance, which if you use a distance formula, you would just subtract 2 square roots of x minus negative 2 square roots of x. You should be able to convince yourself that the length of a diagonal then is 4 square roots of x. And we remember the formula for area of a square is equal to side squared. So if we know the diagonal, and this is a side and this is a side, we can use the Pythagorean Theorem to remind us that side squared plus the other side squared is going to equal to the hypotenuse squared, or that 4 square roots of x quantity squared. So because we just created a right triangle there with the diagonal. So then that would be 2 side squareds is equal to 16x. And then if you divide by 2, you get that s squared is equal to 8x, which is exactly what we're looking for because the area of a square is just side squared. So coming back to this integral then, the volume will be equal to the integral from 0 to 19 of the side squared, which is 8x, and then dx. Now we remember the basic formula when you're integrating, if you're just going to integrate x to the n dx, right, as long as n is not negative 1, is you add 1 to the exponent and put it over it. So that would be x to the n plus 1 divided by n plus 1, and then you would normally have a plus c. But in this case, it's not going to be an indefinite integral because we have definite limits. So we'll apply the fundamental theorem here. So this then becomes, the exponent is understood to be 1 here, so we're going to add 1 to that, which will be 2, and we'll put it over that, which will put it over 2. So this is going to be 8x squared divided by 2, evaluated from 0 to 19. And then so you could just say, okay, well that's 4x squared evaluated from 0 to 19. The fundamental theorem means you plug 19 in and you plug 0 in. So the 4 is just a constant, so you can bring that out in front, and then you can say it's 19 squared minus 0 squared. And then 19 squared is 361. So it's going to be 4 times 361, which is then the, let's see, that'll be 1,444 will be your final answer on that problem. Okay.